When hiring an electrician for an old house wiring project, there are several important questions to consider. Firstly, inquire about their experience in working on old electrical wiring systems. Old houses often present unique wiring challenges that demand specialized knowledge and skills. An electrician familiar with these systems will be better equipped to identify potential issues and provide appropriate solutions. Secondly, ask if they are willing to provide a quote for the project without an initial site visit. While a site visit is ideal, some electricians may be hesitant to invest time in quoting a project without seeing it firsthand. Finding those willing to provide an initial estimate can help narrow down your list of potential contractors. Thirdly, inquire about the type of wiring they recommend for your old house. There are several wiring options suitable for older homes, including knob and tube, non-metallic sheathed cable NMB, commonly known as Romex, or a combination of both. Each has its advantages and disadvantages, so it's important to understand the electrician's reasoning behind their recommendation. Fourthly, determine if they have any limitations on the size or scope of the project. Some electricians may prefer smaller, less complex jobs, while others are comfortable tackling larger renovations. Be upfront about the extent of your wiring needs to ensure they are a good fit. Fifthly, discuss their pricing structure. Electricians may charge by the hour, by the job, or a combination of both. Understanding how they calculate their fees will allow you to compare quotes from different contractors and make an informed decision. Sixthly, request references from previous customers with similar projects. Speaking with past clients can provide valuable insights into the electrician's quality of work, professionalism, and customer service. Seventhly, and most importantly, verify that they are licensed and insured. A licensed electrician has met the necessary qualifications and is authorized to perform electrical work in your area. Insurance protects you from liability in case of accidents or damages during the project. In addition to these questions, consider contacting an electrician who specializes in historic home restoration. These specialists have extensive experience with older wiring systems and can provide valuable guidance. Be prepared to provide photos of the existing wiring or detailed description of the electrical situation in your home. This will help electricians assess the project and provide more accurate quotes. Obtain multiple quotes from different electricians to ensure you are getting a fair price for the work. Electrical projects in old houses can be complex and time-consuming. Be patient and understanding throughout the process and maintain open communication with the electrician. There are several types of wiring that you might encounter in older homes or that an electrician might recommend for use. Knob and tube wiring was an early standardized method of electrical wiring in buildings common in North America from about 1880 to the 1930s. It consists of single insulated conductors run within wall or ceiling cavities, supported by ceramic knobs and tubes. While it can be relatively safe if properly maintained, it's often considered outdated and may not meet modern safety standards. Non-metallic sheathed cable, or NMB cable, commonly known as Romex, is a type of electrical wiring used in residential buildings. It consists of two or more insulated conductors enclosed in a plastic sheath. NMB cable is generally more cost-effective and easier to install than other wiring methods, making it a popular choice for new construction and renovations. Armored cable, or AC, also known as BX cable, consists of insulated conductors wrapped in a flexible metal sheath. It provides additional protection against physical damage and is often used in exposed locations or where conduit is not required. Conduit is a metal or plastic pipe used to protect electrical wiring. Wiring is run inside the conduit, providing a barrier against moisture, corrosion, and physical damage. Conduit is commonly used in commercial and industrial buildings, as well as in residential applications where extra protection is needed. When selecting wiring for an old house, it's important to consider the existing electrical system, the age of the house, and local building codes. An experienced electrician can assess your specific needs and recommend the most appropriate wiring method. When evaluating electrical work, it's helpful to understand common terms and concepts. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Common voltage levels in residential wiring include 120 volts for lighting and small appliances, and 240 volts for larger appliances like ovens and dryers. Amperage is the measure of electrical current flowing through a circuit measured in amps. The amperage rating of a circuit breaker or fuse determines the maximum amount of current that the circuit can safely handle. Wattage is the measure of electrical power consumed by a device, calculated by multiplying voltage by amperage. Understanding wattage is important for determining the appropriate size of circuit breakers and wiring. Resistance is the opposition to the flow of electrical current measured in ohms. The resistance of a wire affects the amount of current that can flow through it. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow in the event of a short circuit. Grounding helps to prevent electrical shock and fire hazards. Ground fault circuit interrupters, or GFCIs, are devices that monitor the flow of current in a circuit and quickly disconnect the power if a ground fault is detected. GFCIs are commonly used in bathrooms, kitchens, and outdoor areas to protect against electrical shock. Arc fault circuit interrupters, or SIs, are devices that detect arcing faults, which can cause fires. SIs are typically installed in bedrooms and other areas where there is a high risk of fire. Electrical codes are sets of regulations that govern the safe installation and use of electrical wiring and equipment. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. Local building codes may also have additional requirements. Permits are required for many types of electrical work, including new installations, renovations, and repairs. A permit ensures that the work is inspected and meets safety standards. Electrical inspections are conducted by local building officials to verify that electrical work complies with code requirements. Inspections help to ensure the safety of the electrical system and protect against potential hazards. When working with electrical wiring, it's essential to follow safety precautions to prevent electrical shock and fire hazards. Always turn off the power to the circuit before working on any wiring. Use insulated tools to avoid contact with live wires. Wear safety glasses to protect your eyes from sparks and debris. Never work on electrical wiring in wet or damp conditions. If you are not comfortable working with electrical wiring, hire a qualified electrician. When hiring an electrician, be sure to check their credentials and references. A licensed electrician has the knowledge and experience to perform electrical work safely and correctly. Ask for proof of insurance to protect yourself from liability in case of accidents or damages. Get a written estimate before work begins, outlining the scope of the project, the cost of materials, and the labor charges. Understand the electrician's payment terms and warranty policy. Communicate clearly with the electrician about your expectations and any concerns you may have. If you are renovating an old house, consider upgrading the electrical system to meet modern needs. This may include adding new circuits, upgrading the service panel, and installing energy-efficient lighting. Replacing old wiring can improve safety, increase capacity, and enhance the value of your home. Consider installing smart home devices, such as smart lighting, thermostats, and outlets to improve energy efficiency and convenience. Smart home devices can be controlled remotely using a smartphone or tablet. Be aware of common electrical problems in old houses, such as overloaded circuits, loose connections, and outdated wiring. These problems can lead to fire hazards and electrical shock. Have your electrical system inspected regularly by a qualified electrician to identify and address potential problems. If you notice any signs of electrical problems, such as flickering lights, burning smells, or tripped circuit breakers, call an electrician immediately. Do not attempt to repair electrical problems yourself unless you are a qualified electrician. Electrical work can be dangerous and should only be performed by trained professionals. By following these tips, you can ensure that your old house has a safe and reliable electrical system. Remember to prioritize safety and hire a qualified electrician for any electrical work. The NEC, or National Electrical Code, provides comprehensive standards for electrical installations. It's updated every 3 years, and local jurisdictions often adopt the latest version. Article 90.3 of the NEC covers the arrangement and organization of the code, which is divided into chapters, articles, and sections. Chapter 1 of the NEC covers general requirements, including definitions, wiring methods, and grounding. Chapter 2 covers wiring and protection, including overcurrent protection, grounding, and wiring methods. Chapter 3 covers wiring methods and materials, including conductors, cables, and raceways. Chapter 4 covers equipment for general use, including switches, receptacles, and lighting fixtures. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment, including electric signs, swimming pools, and elevators. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems, including telephone, data, and cable television. Chapter 9 contains tables and examples that provide guidance on applying the NEC requirements. When working with electrical wiring, it's important to consult the NEC and local building codes to ensure compliance with safety standards. Article 110.12 of the NEC addresses neat and workmanlike manner, requiring electrical work to be installed in a neat and workmanlike manner. This includes properly supporting and securing wiring, making clean connections, and labeling circuits. Article 210.8 covers ground fault circuit interrupter GFCI protection for personnel. GFCI protection is required in bathrooms, kitchens, and other locations where there is a high risk of electrical shock. Article 250 covers grounding and bonding, providing requirements for grounding electrical systems and equipment. Proper grounding is essential for preventing electrical shock and fire hazards. Article 300 covers wiring methods, providing requirements for installing conductors, cables, and raceways. The wiring method must be suitable for the environment and provide adequate protection for the conductors. Article 310.15 addresses ampacity, which is the current carrying capacity of a conductor. The ampacity of a conductor must be sufficient for the load it will carry. NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. Article 400 covers flexible cords and cables, providing requirements for their use and installation. Flexible cords and cables are commonly used for portable appliances and equipment. Article 404 covers switches, providing requirements for their installation and use. Switches must be properly rated for the voltage and current they will control. Article 406 covers receptacles, providing requirements for their installation and use. Receptacles must be properly grounded and protected by GFCIs where required. Article 408 covers panel boards, providing requirements for their construction and installation. Panel boards are used to distribute electrical power to branch circuits. Article 410 covers lighting fixtures, providing requirements for their installation and use. Lighting fixtures must be properly supported and wired. When planning electrical work, it's important to consider the load requirements of the appliances and equipment that will be connected to the circuits. The load calculation should include the wattage of all lighting fixtures, receptacles, and appliances. The total load should not exceed the ampacity of the circuit. When selecting circuit breakers, it's important to choose the correct size for the circuit. The circuit breaker should be rated to protect the wiring from overload and short circuit. A circuit breaker that is too small will trip frequently, while a circuit breaker that is too large will not provide adequate protection. When installing wiring, it's important to follow proper techniques to ensure safe and reliable connections. Use wire connectors to make secure connections between wires. Wrap electrical tape around wire connectors to insulate them from moisture and corrosion. Properly support and secure wiring to prevent damage and strain. When working with electrical wiring, it's important to be aware of the potential hazards. Electrical shock can cause serious injury or death. Fire hazards can result from overloaded circuits, loose connections, and damaged wiring. Always turn off the power to the circuit before working on any wiring. Use insulated tools to avoid contact with live wires. Wear safety glasses to protect your eyes from sparks and debris. Never work on electrical wiring in wet or damp conditions. If you are not comfortable working with electrical wiring, hire a qualified electrician. Remember that electrical work can be dangerous and should only be performed by trained professionals. Prioritize safety and follow all applicable codes and regulations. By taking these precautions, you can ensure that your electrical system is safe and reliable.